What are we trying to do with any equation? Solve for the variable. Here I see two different variables and I see them on different sides. So before we get obsessed with the numbers and moving the constants to whichever side, let's focus on the variables. They want to be alone, but in this case, whether I choose to cancel out the variable on the left to in effect move it to the right, or whether I want to cancel out the one on the right to move it to the left, regardless, it's the same step, which is going to be to add n to both sides. And when I do that, all the n's cancel. So the other thing I said yesterday, I don't know if you picked up on it, was that another common mistake occurs. This is probably even more common, where too many people just rush to the assumption and say, oh, no solution. Well, yes, you are correct that now there is no longer a variable to solve for, so we can no longer solve. Somebody brought up yesterday the fact that on the Khan Academy, one of the lessons deals with number of solutions, not necessarily solving, but just talk about how many solutions. Linear equations. What makes this linear? We talked about linear already. What makes this type of equation linear? There are variables, but those variables are being taken to what power? To the first power. That's what makes it linear. Yeah. Linear equations typically have one solution, except in these situations. If all the variables cancel, the only thing I know is that I'm not going to have one solution. So when you do the Khan Academy thing, at this point now I know that I cannot have exactly one solution. But to figure out how many solutions I have, I need to drop the leftovers. And I'm left with a statement that originally read that negative 24 was equal to 5. Is that true? It is not true. So this means it does not equal. And yes, that's why there's no solution. If I would have been left with two numbers that are equal, it wouldn't be no solution. It would be the opposite of no solution. That's coming up next. If your time is too precious and you don't feel like writing out the entire no solution, there is a symbol for it. It's called the empty set. It's like a 0 with a diagonal line through it. That would suffice as well. This means no solution. Better today, right? Makes more sense today. Okay, here's another equation. I want to solve, but if we understood that an equation is just two equivalent expressions, I recommended to you, I strongly recommended to you that before we start getting carried away with solving, let's make sure that both individual expressions are simplified. The left side here is simplified. I cannot add 5y plus 2, but I see a parentheses on the right side, which has to be, there has to be a way to get rid of it. So how can I get rid of that parentheses? Yes, Lorna?
Distribute 1/2.
You could distribute a 1/2. What is 1/2 of 10?
10/2.
5, yeah. And what's half of 4? 2. So this is just kind of a long way of writing it out, but the point is that we get to here, which is now an equation that reads 5y plus 2 is equal to 5y plus 2. I just verbally explain, even if you don't understand what's going on the right side there, I'm just showing you the numbers that cancel. I verbally explained to you why I got 5y plus 2 equals 5y plus 2. At this point, it could be obvious to you what's going to happen, but just to prove it, my focus is still on the variables. I'm still trying to isolate. I still see two variables. I want them to be together, but just like on the last example, no matter which variable I try to move, I subtract 5y on both sides, and no more variables. There's nothing to solve for. I'm trying to solve for a variable, but all the variables are gone. They're bye-bye. The slash is like an eraser. Gone, from wiped off the face of the earth. So then Mr. Romero said, okay, well, when that happens, don't just assume no solution. Just drop what's left over as if it was hot. Now here we have another statement of equality, but the difference is this one's true. When you have a true statement, that doesn't mean that there is no solution. That doesn't mean that there isn't a number that would make both sides equal. That means that every number, every real number that exists on a number line would make the equation true. I could go one by one. Give me your favorite number. 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 And every single number you give me, I would put back into the top of the equation, and I would end up with two equal sides. If you look on Khan Academy, I believe Khan Academy calls it infinitely many solutions. That's fine. You can also call it all real numbers. And again, if you want to save time, this is a symbol for real numbers. It's like an R, but with an extra little vertical line through it. It just means that it isn't that there's no solution, it's just it's every solution.
That's so.
Remember whatever you want to. Okay, so the question is, do we have to write all real numbers? Why do you think I would give you a shorter way of writing all real numbers? No? Okay, then yes, you have to write it. If your name is Brian, you have to write down all real numbers. Just write the whole thing. Everybody else can write the symbol. And then the last thing is just for your information. If it were to ever come up, an equation. Now I'm not talking about the solution. I'm talking about the equation itself. An equation that happens to have all solutions, where the solution is earthing, you call that an identity. It can be referred to as an identity. Because the equation has an infinite amount of solutions, the equation can be referred to as an identity. No other questions? Cool. Okay, then the last one, this will be the fourth time in 3 days that you see this. So maybe now we can get it without assistance. Very good. Look at that. Code is on fire. Good. When you have two equal fractions, this is referred to as a proportion. It's still an equation, but it has a special name. And not only does it have a special name, there's a special way to solve it. Very good. Last period, I got the answer. Very good, Brian. Cross multiply. If two fractions are equal, then by rule, their cross products have to be equal as well. What does product mean?
Multiply.
Multiply. Cross means numerator with denominator and vice versa. So 4 times x would have to be equal to negative 3 times 26. Whoa. But how about if I wrote 4x equals negative 3 times 26? I wrote it backwards. That's fine. You just got to make sure that what's being multiplied are what's diagonal from each other. The negative 3 with the 26, the 4 with the x. Negative 3 times 26 is negative 78. And that's equal to 4x. Tab, last step, to get x by itself and live happily ever after. Good, divide both sides by 4. And yeah, now we're allowed the calculator. What? Whoop. Put that into your calculator. For real? It is negative 19.5. Yeah! If you put negative 19.5 on Khan Academy, it'll mark it right. If you were to put it on a test or a quiz, I would probably mark it right. Because it's right, it's exact. But now here's what I'll offer you. Let's pretend that wasn't a 4. Let's say it was a 7. Put negative 78 divided by 7. Oh. What you should have now is a decimal that fills up your screen. If you put what's on that screen, Khan Academy will mark it wrong. I would mark it wrong. And the Georgia EOC would probably mark it wrong as well, because it's filling up your screen, but it's only filling up your screen because it doesn't have enough space. If it had more space, it would go on to eternity. Yes, it will repeat. There is a repeatable pattern there. But the point I'm trying to prove to you is that every decimal can be written as a fraction, but not every fraction can be written as a decimal, because some go on forever. So instead of overly relying on the calculator, let's just, the way that we can, because this symbol here means exact. I want to know exactly what x is. I don't want to know kind of what x is. I want to know exactly what x is. So let's just say that these can't be divided completely because we want to stay away from decimals. What other number do we know that I can divide both of those by? Since they're both even. 2. 2. So divide them both by 2 instead, and then we'll live happily ever after in the land of fractions. Leave it as negative 39 over 2. You saying it somewhere? Mm-hmm. Any questions there? And again, what are we dealing with here? What are we dealing with here? A proportion, which we've solved before. But now, what I believe what makes this one unique, if I'm correct, this is the first time the variable appears in the denominator. So when it appears in the denominator, now you're kind of forced into cross multiplying. We've solved these before, but we've done it more conventionally, just by getting rid of what's around the variable. Like here, you'd be like, oh, look, just get rid of the 15. It becomes a little more complicated if the variable's in the denominator. No, it would not equal 1. But what you could do is cross multiply. And look, the other nice thing about cross multiplication, what don't you see anymore?
Fractions.
There's no more fraction. We like it's a way to get rid of a fraction. 15 times dos is 30 divided by 3 is 10. A equals 10. You've been working out, so you're trying to stretch out the armhole. Well, because I saw yesterday you were rolling up your sleeves and then now you're stretching out. I figured you were doing some extra bicep curls. Gotcha. Any questions there? No. Okay, last one before you get your test back. And what's different about this one? The first numerator has 2 terms. So that's fine. I said it better, but that is what you said. If you paid attention to the notation that, remember you said cross multiply, what have I been using to show multiplication? Well, not just now, but always.
Parentheses.
It becomes even more critical here to use parentheses. Some of you are still infatuated with the dot. That's the first way I learned in pre-algebra, and you want to do everything with the dot for multiplication. Some of you are still stuck in elementary school and they're using the X like for arithmetic. But don't get used to parentheses, especially here, because now that entire b plus 4 needs to stay in a parentheses before you multiply it with the 4. Because when you do multiply, what type of multiplying do you have to do? Distribute. Good. 4 times b plus 4 is 4b plus 16. That's equal to 35. And then we subtract 16 from both sides. And we get 4b is equal to 19. Long live the calculator. Sure, divide by 4. I can't do that in my head, but my calculator can. And it gets 4.75. Bam! If you put that on Khan Academy, it'll work. If you put that on a test, it'll work. And at least there you're lucky that it's exact. But if that's all you know how to do is use a calculator, when it's not exact, when it repeats and goes on forever, all you're going to know how to do is round and you will get it wrong. So better than that is just say, okay, I got a decimal. I don't want the decimal. What did we do the last time around?
It is fraction.
Well, it's already a fraction. But what did we do with that fraction? Well, we reduced. Instead of dividing by each other, we found another number to divide by. Is there another number that fits into both 19 and 4?
Nope.
No, 19's prime. So guess what? Even easier. Just leave it alone. B is 19. What we're trying to do is isolate the variable, and I did that. We isolated it. We so happy. Happy, happy, joy, joy. Any other questions there? So that is enough now to cover the entire week's worth of assignments.